Okay, so here we go. Get ready to pay attention. All right, we are on page 6 today, and here we go, page 6. Isosceles and equilateral triangles. Okay, if you are having a conversation right now, you need to stop. You can talk later. Okay, parts of an isosceles triangle. The two congruent sides are called the legs. Okay, that's what we call those. The angle where the sides intersect, this one here, this is the vertex angle. Okay, and then the side opposite of the vertex angle, this is the base. Okay, this is a leg, this is a leg. Okay, and then these angles here, these angles, they surround the base and they are across from each leg diagonally. Those are your base angles. Okay. Ultimately, your base angles are congruent. Your legs are congruent, and the angles opposite of those legs are also congruent to each other. All right. If two sides, actually, let's do this. Your base angles are congruent. Probably want to write that down. Your legs, those are congruent. Okay, so the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of those sides are also congruent. So if segment AB is congruent to segment CB, those are my legs, then, and pretty much remember, we can put everything in geometry in an if-then statement. If this, then that. Okay? Then, angle A is congruent to angle C. That's the theorem. Now the converse of that, remember that converse, it's not the tennis shoes, right? But it sounds like reverse. We just flip-flop those. Okay, if the two angles along the base are congruent, then the sides opposite those angles are also congruent. So if angle A is congruent to angle C, then AB is congruent to CB. Okay, so all I did was flip-flop it. I didn't make up any new info. Okay. So here are just some little practices for us to do together. So we're going to have you find missing angles and missing sides. That's ultimately what we're going to have you do. We're going to give you some straight number questions, and we're going to give you questions that involve algebraic equations. Before you do anything, personally, okay, here are my legs, and then I would then do the angles. Those angles are congruent. They have one arc. Those legs are congruent. They have one tick mark. So, angle J is congruent to angle L, right? So it'd be 68 degrees. Okay, you don't have to label the triangle, but I just did for you. If both of those angles are 68 degrees, how do you get angle K? What do you do? Tell me.
So you add angle J and angle L, and then you subtract that from 180, and that'll give you K.
Okay. How many of you would like me to show you how you can type that all into the calculator at one time? Anybody like knowing how to do things in one step? Okay, so if it were me, I would do 180 minus parentheses 68 plus 68. Now this is exactly what he said. I add the 2 and subtract from 180. You can do it that way. The other way you can is 180 minus 68 minus 68. And then hit enter. You get the same answer. The other option is 180 minus 2 times 68. That would be the other way you could enter it. You get the same thing. Personally, I do not care which way you do it. Right? Doesn't matter to me. There we go. I don't care which way you do that. But do you see the difference in the calculator? Yes? Okay. Alright, let me get this to freeze again. Is it going to keep moving? Okay. Okay. So here we have 106. That is our obtuse angle. That is our vertex angle. So I know that E and C, those are going to be congruent angles. And I know that CD and ED are congruent. Those are my legs. So this is my vertex angle. That is not the same as the base angles. So how would I get the measure of C and E? Tell me.
You would, because the sides are congruent, the C is going to be equal to E.
Okay.
So you subtract 106 from 180, and then you divide that by 2.
Ah, so 180 minus 106, and then I can divide by 2. You can actually stick that in your calculator as well, all in one step. Put 180 minus 160 in parentheses, or 106. So put that in parentheses, and then just do divide by 2. It'll look exactly like what's on your paper. And then we have 37. So if C is 37, E is 37. Okay, all right. Next one over here. Now we're dealing with one side and one angle. Okay, again, my sides are going to be congruent. So I know that YZ is also 12 centimeters. And then my base angles are congruent. I can see that. Here's 77 here and 77 there. So the way we did number 1 is how you would do this one over here. Okay, so 180 minus 2 times 77. I like that method. I get 26. 26 degrees. Okay, and now we are to some algebra. Let's see what we have. This we are going to deal with two angles. So it looks like 4 and 5 are very similar. And it looks like 6 and 7 are very similar. So I would like to just do one of each. Okay, one of each type. So I would like somebody to choose. Somebody choose between 4 or 5. 4. Got it? Okay, somebody choose between 6 and 7. Okay, vote. Raise your hand for 6. Raise your hand for 6. Raise your hand for 7. Okay, got it. Oh, look, it looks like vertical angles, doesn't it? Did you see that? I know, I can find the math on anything. Okay, here we go. If my legs are congruent, then my base angles are congruent. So those are equal to each other. 5x plus 9 equals 8x minus 30. All right, subtract your 5x because it is smaller. All right, so if I get rid of 5x on the left, Okay, that 30 has to move to the other side. Yes. So I'm going to add 30 to both sides. I now have gotten rid of a zero pair on both sides. So 9 plus 30 is 39. 8 minus 5 is 3 x's. Divide by 3. So x is 13. Now, if I wanted to, I could ask you to tell me the measure of the angle. I'm just currently asking you to find x. By the way, and I don't remember which class periods it's been a big issue in, but when you are moving your variables, okay, please keep the x with the coefficient. It doesn't come off until the very end. And I've seen some people, like, they'll just do -5, and then they'll -5 over here with the 30, which is not correct. So I know, right? It's weird. So please keep your x's with your coefficients until the very end. Okay, now here, I can see that my base angles are congruent. How do I know that they're base angles? Because if I go like that, this is my vertex angle way up here. Okay? All right, so my base angles are congruent, which means my legs are congruent. This is the converse. Okay, this is the theorem here, and this is the converse here. So I know that I'm going to have 9x minus 73 equals 3x plus 23. All right, I'm going to move the 3x because it is smaller, like this. That goes away. It's a zero pair. I'm going to add 73 to both sides, so that is gone. 9x's minus 3x's is 6x, and 23 and 73 is 96. And then we divide by 6. I don't know that. Thank you. Is it 16? Yeah. Thank you. As I say, I don't know that one in my head. Okay. All right. Now, ultimately, as former algebra students, what would you do if you really wanted to make sure you were getting 100? What could you do? Put it back in right here and make sure that each leg is the same measure. Put it back in here and make sure that each angle is the same measure. Okay, so this is isosceles triangles. Okay, now we're going to flip over and go to equilateral. Okay. All right. Here's your triangle right here. Okay, a triangle is equilateral. Lateral means sides. If and only if it is equiangular. Okay, so we've talked about that already. We have talked about that if you see an equilateral triangle, the angles are all the same. And what number are they? What number are the angles? They're all 60, okay? If you see 60, 60, 60, what do you know about the sides? Equilateral. They're equilateral. They're congruent. Okay, so over here, if angle A, angle B, and angle C are all equal to each other, then segment AB, so let's do this. That and that and that are all the same measurement. So that means that segment AB equals segment BC, which equals segment CA. Okay, they're all congruent. So over here, one tick mark, and one tick mark. Now, if you can't remember, 180 divided by 3 is 60. So all of these are 60 degrees. 60 here, 60 here, and 60 there. Okay? Now, the flip of that is if all of your sides are equal, then you know that the measure of angle A equals the measure of angle B, which equals the measure of angle C. Okay? And they are all equal to 60 degrees. That's a given. You kind of need to memorize that. Okay? So let's do a couple of these. All right, right here we have to find angle C. We have to find BC and AC. This was the most basic of the kinds I can give you. 60, 60, 60. Let's say you looked at that and you're like, well, I don't know if that's isosceles or not. Because you could look at it and say, well, my base angles are the same. Right? You could look at that and think it's an isosceles triangle. You could. So what you can do is 180 minus what? Okay, minus the 120, you know you're going to get 60 right here. Okay, so you can always do the math if you forget. Then, once you see that you have 3 congruent angles, you automatically know that all of the sides are congruent to each other. So the other 2 sides are 9 and 9. Okay? All right, so over here, you're given this information. Congruent, congruent, congruent. They're all 24, but we want to know the measure of the angles. If you have an equilateral triangle, what do you know? All of the angles are the same, right? It's equiangular, so it is automatically 60, and you don't have to even think about it. Okay. Now, this one here, you can see that you have 3 congruent legs, right, or 3 congruent sides, so it's equilateral, which means it's equiangular. So this angle and this angle and this angle are all equal to each other. How do you get x? What do you think?
Then you put 4x plus 8 equals 60. And you solve for x.
You can. You can do 4x plus 8 equals 60 and solve for x. What's another way you could solve that? How about we do 3 times 4x plus 8 equals 180 degrees, right? I got 3 of them. They're all the same. And all 3 angles would have to add to 180, right? So that's 2 ways you can do it. I don't really care which one you use. Some people will forget that they can just take this little shortcut right here. Okay, what's 52 divided by 4?
13.
Man, 13 is coming up a lot today. Must be because my daughter's turning 13. Okay, if you did it this way, you should also get 13. All right, over here. Now, I want to point something out to you, and I kind of already alluded to it. If you have, kind of want to talk about this. If you have 2 angles that are the same, like this, what do you know about the legs? They're the same, right? So this right here, just looking at that, it looks like it's isosceles, right? Okay. Well, what would be this angle up here? It is also 60. So now I just found out that my isosceles triangle is actually equiangular, which means the base is also the same measurement. So you can have an isosceles triangle that is equilateral. This is an isosceles triangle based on what you see right here, yes? Do you see that? Okay, so boom and boom. That's isosceles, right? But when I do the math and I figure out that the angles are all 360, that's equiangular. So my isosceles triangle is also equilateral. Not all. Let's write this down. This is kind of like the rectangle square conundrum. All equilateral, equiangular triangles are also isosceles. They are. They have the characteristics of an isosceles triangle. The base angles are the same and the legs are the same. Okay? Only some isosceles triangles. We saw on the previous page, were these equilateral, equiangular? No. So some of the isosceles triangles in the world are equilateral, equiangular. Okay, so it's kind of like the rectangle square. All squares are rectangles, but only some rectangles are squares. And we will get to that. Okay. Let's do this really, let's see. What do we got back here? Okay, let's do this puzzle, and then I'm going to let you choose the ones that are left for me to work, and we'll decide what we do, and then I will give you your assignment. And the last 10 minutes of class, I'm going to give you a skills check on yesterday. Okay? All right, here we go. Bless you. Okay, this and this are congruent, yeah? Okay, so what can you do first? That equals that. Okay, so 4x plus 3 equals 9x minus 47. We subtract our 4x from both sides. We add 47 to both sides. So we get 50 is equal to 5x. So x is equal to 10. That's just x. We've got to do our angles. So for C, it is 9 times 10 minus 47. 90 minus 47?
43.
Okay, so C is 43 degrees. Guess what A is?
43 degrees.
43 degrees. All right, so that's angle 9 is 43. And angle A is 1, so that's 43. Yes? Okay. And then, let's see. What else can you do? Yes?
Well, it says that triangle DBE
Yep.
is equilateral,
Yep.
which means it's equiangular, which means all of them are 60. So you can find 3 and angle 8.
Okay, hold on. Hold on. Let's pause at the they're all 360 part.
Oh, yeah. You can
So
find
4, 5, and 6 are all 60. Okay. So if you're someone who does not read the given information, you might miss that. Be sure to read those. Okay. And then how are we going to get the others?
So you know that 2 and 7 are 60 because, or no.
2 and 7 cannot be 60.
Oh wait, never mind.
How would I get 3?
You could do 180 minus 60.
And what would that give you?
120.
And which ones are 120?
3 and 8.
Perfect. So 120 here. And that's an obtuse number, and that's an obtuse angle, so that makes sense, right? Okay, now I know 2 I know 2 of the angles out of the 3. This is 43 degrees. This is 120 degrees. How do I get 7?
180 minus 7 minus 1.
Okay, what is it?
17.
Okay. And that means this is also 17.
Yeah.
All right, very nice. Okay, so number 1, I think that's pretty easy. They're both what? They're both 60. Number 2, we want to find the base. This is an equal angular, so there'd be an equilateral. So to solve this one, 9r equals 5r plus 8. Does anyone need me to work that? Okay, once you find r, then you substitute in. Go to your next page. Okay. Ooh, we probably want to look at number 3. I think we should do number 3. Okay, number 6, what kind of triangle is that? That's going to be an isosceles triangle. That would be easy to find, x and y. Okay. Number 4, that's equilateral, so it is also equiangular. It would be easy to find n. Okay. What do you think about 5? We're going to do 3, but what do you think about 5? I think we need to do 5. Let's do 3 and 5. Okay, on number 3, what I notice when I turn my paper around is I have that right there, yes? Do you agree? Okay, so that means this angle here and this angle here, Q and P are congruent. This is angle R. It's our vertex angle. And the vertex angle in this picture is not congruent to the other. I don't know anything about the base, so I cannot say that it's equilateral. But what I can say is that I have 2 of my base angle, right? Because this one is also 3x plus 3. I have 2 of those. And then I have 1 of these at the top, this vertex angle, and they all have to add up to what number? 180. So now I can solve that. If you don't want to write it all out over here, you can be like 3 plus 3 plus 5. So that's what, 11? You could write it out like that. And then you have 3 plus 3 take away 2. So 6 take away 2 is 4. So you could write it out like that. Okay, so over here I combined like terms visually. If you don't want to do that, you could write out the full algebraic equation here like I did. If you were to distribute and combine like terms, you should get that. Then I can subtract 4. So 11x equal to 176. Let me guess. It's 16. We were close. Okay, now that's just x, but what is it asking me to actually find? So Q and then P and then R. It wants me to find that angle right there, which is how much? It's your 3x plus 3, right?
Yeah.
QPR equals 3 times 16 plus 3. How much is that?
Actually, let me check that.
Okay, 51 degrees. All right, and our last one. Okay, a couple of things I notice. Right here I have this and I have this, which means this right here is congruent to this one over here. So this is 6y. Yeah? Yes, no? Okay, so here's the thing. This is 60 degrees. If I did 180 minus 60, I get 120. And then, so these two together are 120 degrees, right? Those two together, if I add them together. So if I divide by 2, I get what? I get 60. So my angles are indeed 60 apiece. Yes?
Yep.
So y is 10. Okay? And then right here, I can see that my legs, actually and my base, but my legs are the same. So 3x plus 8 is equal to 23. Subtract 8. 3x is equal to, what is that, 15? Did I do that right? And then 15 divided by 3 is 5. Okay? So you really don't assume anything. Think about everything.
Okay.
Does that make sense? Okay, I'm going to pass out your assignment. And you're going to have about 12 minutes to work on your assignment. It's only one-sided. And then in about 12 minutes, I'm going to give you your skills check. That is based on yesterday's assignment. Okay? If yesterday's assignment is done, you can check it. The key is over here. The little half sheet is not for first period class. It's only for third and sixth.